In this last section in Chapter 14, we're going to look at some more complicated problems involving binomial probabilities. In this section, I'm going to demonstrate a calculator shortcut that you can use. So if you have a graphing calculator of your own, I'm going to show you how to do this on your graphing calculator, and that will be a little bit of a time saver for you. If you don't have a graphing calculator, you can still do it by hand. It's just a little bit more time consuming. So here's the binomial probability formula that we used in section 14.7. But the Texas Instrument calculators have a shortcut for binomial probabilities built in, and that's part of the VARS menu. And so we're going to kind of walk through the steps for how to do that. It's going to ask for three numbers, and the three numbers that it wants are N, P, and K, which are the three numbers that we had to identify to use the formula anyway. And you're going to plug them into the formula using commas, but some newer versions of the calculator will actually ask you for the number of trials and things like that. So if you have a newer calculator, you can probably figure it out based on what we're doing in this demonstration. So we're going to do example one, which we looked at in the last section, but we're going to do it with a calculator shortcut. So here, remember, we have Drew Brees, who's attempting 5 passes. He completes 70% of his passes, and we want to know the probability that if he attempts 5, he will complete 3 of them. We defined success as completing a pass. So we said that N, the number of trials, was 5. The probability of success, P, is 0.7, and K is 3 because we're calculating the probability of completing 3 passes. So if you have a graphing calculator, you want to access this menu right here. And this is the distribution menu. And the way you access that is by hitting the second button and then the VARS key. And notice above that it says DISTR, that's distribution. Now you're going to scroll down through that list, and when you get to about the 10th or 11th option, you might notice one that says Binom PDF, and that's the one you want to choose. On my calculator, it's the 10th option, but sometimes different versions might have more or less options to choose from. So look for the one that says Binom PDF, and you're going to select that. So choose that one right there. And then on my calculator, I have to put in N into the parentheses, followed by a comma, and then the probability of success, which is 0.7, then another comma, and then 3. And I closed the parentheses, and when I hit enter, it gave me that decimal of 0.3087. Now the comma button, in case you've never used it before, is the one that is immediately above the 7. So I'm going to write down here what we typed in our calculator, and I would recommend that you write that down in your notes as well. So when you go back later, you remember how you came up with that answer of 0.3087. Now in example 2, this is a good example of when the calculator shortcut will come in handy for us. This one says if he attempts 5 passes, what is the probability he will complete 3 or 4 of them? So N is still 5, P is still 0.7, but K now is going to be either 3 or 4. And we know that when we see or in probability questions, or means add. So we're going to have to calculate 2 separate probabilities and then add the results together. So using my calculator shortcut, I'm going to do the binomial PDF, and I'm going to put in N, P, and I'm going to do K as 4 in this case, because I already calculated the probability that he completes 3 passes. That was example number 1. So I'm going to do this to calculate the probability that it completes 4 passes, and that gives me 0.3602. So now the probability that he completes 3 or 4 will be the sum of those two decimals. And that 0.3087 was what I calculated in example 1, plus the new probability that I just calculated for a total probability of 0.6689. In example 3, we're looking again at Ted with his weighted coin. We know that he's tossing 8 times, and the question says, what is the probability that more than half of the tosses will show heads? So N is 8, P is 0.75. Now, more than half would be more than 4. So more than 4 would be either 5, 6, 7, or 8 tosses. In this case, we would have to do 4 separate calculations, and this is where the shortcut is really going to come in handy. So to calculate the probability that he tosses heads 5 times, we would do this calculation. To calculate 6 tosses landing showing heads, all we have to do is change that last number to a 6. This would be the probability that 7 of the tosses land showing heads. And then this would be the probability that 8 of the tosses land showing heads. And then we're just going to add those all together for a grand total of 0.8862. Again, because it says or, we're going to add. In example 4, the tennis player making 60% of his first serves. If we want to know the probability that if he serves 5 times, he will miss at least 4 of them. Here, we're defining success as missing the serve. He's serving 5 times. The probability that he misses the serve is 0.4. And then K, remember, is at least 4. At least means 4 or more. And because he's only serving 5 times, that would mean he would miss 4 or 5 of them. So we use our calculator shortcut. This calculation will give us the probability that he misses 4 of them. This would be the probability that he misses 5 of them. Now 4 or 5 would be the sum of those, which is 0.087. In example 5, a basketball player makes 80% of her free throws. Find the probability that if she attempts 5, she will make at least 1 of them. So success in this case is her making a free throw. She's attempting 5. The probability she makes it is 80% or 0.8. And K is at least 1. So at least 1 means 1 or more, which in this case would be making 1 or 2 or 3 or 4 or 5. Now you can do all 5 of those calculations and add them, or you might notice that this is all of the possibilities in the sample space except for one possibility. And the only one that we're not including here is the case where she makes none of her free throws. So we know that for the entire sample space, all of these probabilities have to total 1. So again, I could calculate the probability that she makes none of them, or 1, or 2, or 3, or 4, or 5. And I know that all 6 of these probabilities added together total 1. Well, if I want the sum of all of these 5 probabilities, but I don't want to do all 5 of them separately and add them up, what I could do is just calculate this one probability and then subtract it from the total, and that will tell me what all the rest of them add up to be. So that's the approach that I'm going to take on this one. So I'm actually going to do binomial PDF. I'm going to do my calculator shortcut, but I'm going to put in that K is 0. And that gives me that really, really small probability right there. Now all I have to do is subtract that from 1, and that will give me the sum of the other 5 probabilities in a much quicker way. So 1 minus that number is 0.9997. Now you're free to do all 5 and add them up. This is just a much quicker way to do it. All right, let's try that same shortcut on our last example. A baseball player's batting average is 0.320. That means he has a 32% chance of getting a hit. If he has 10 at-bats, what is the probability he will get a hit at least once? In this case, success is getting a hit. He has 10 attempts because he has 10 at-bats. Probability of success is 0.32. And K, again, it says at least 1. It would be anything including 1, 2, 3, 4, and anything up to and including 10, which would be 10 separate probabilities that we would have to calculate. So rather than doing those 10, let's just calculate the one we are not including, which is 0, and then subtract that from the total for our sample space, which is 1. So I'll use my calculator shortcut. We'll do binomial PDF with those parameters. And that gives me a probability of 0.0211. Therefore, the probability that he gets at least 1 hit would be 1 minus that, which is 0.9789. All right, that concludes Chapter 14. Please do the homework for Section 14.8 in your assignment packet.